be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
Fundamentally, at scale, the Optimus robot, you should be able to buy an Optimus robot for, I think, probably $20,000 to $30,000 long term.
The miracle is not that a bipedal machine can lift boxes or pour coffee. Boston Dynamics did circus tricks years ago. The miracle is that Tesla aims to do it at a sticker price comparable to a mid-grade sedan. Why does cost matter? Because usefulness is a function of prevalence. An expensive showpiece is a party trick. A $20,000 appliance is an economic force. Will affordable $20,000 robots revolutionize economies or truly become expensive paperweights prized only by elites? Welcome to Tesla Car World. So, how is Tesla Bot Gen 3 a breakthrough in AI? To hit that price point, Tesla leans on the muscle it has already built in Fremont, Shanghai, Berlin, Austin, and now Mexico. The Optimus actuators, control boards, sensors, and, crucially, the 4680 cells ride the same supply chain superhighway that feeds Model Y production. Every penny shaved off a battery tab weld or drive unit casting echoes inside the robot's bill of materials. In pure manufacturing calculus, Optimus is a derivative of Tesla's existing empire, not a standalone moonshot. Inside the husk of Optimus Gen 3 lies a roughly 3 kilowatt-hour 4680 pack. 5 times the volumetric energy density of the old 2170 format allows engineers to bury power in the torso instead of strapping a brick to the robot's back like a jetpack. The result? 22 pounds shed in a single revision, down to 138 pounds all in. Less weight means smaller motors, lower thermal load, cheaper structural members, and efficiency cascade. When Tesla rolled out the first Optimus prototype on AI Day 2022, the robot could barely shuffle across a stage. Fast forward to May 2025 and the third-generation machine tells a radically different story. It now plucks a tennis ball out of midair, executes a synchronized dance routine, and threads a sewing needle, all on video streams released by Tesla in the space of 6 months. At the heart of that leap sits a brand new end effector, a 22 degree of freedom hand that doubles the articulation of Gen 2, 11 DOF, and closes to within 18% of the human hand's 27 mobile axes. Engineer Milan Kovac, who leads the manipulator team, disclosed that each finger is driven by cable and tendon and paired with touch sensors capable of resolving forces under 1 Newton, a configuration that lifts pinch precision from 5 millimeters to 1.4 millimeters, according to Tesla's internal benchmarking. Real-world footage supports the specifications. In the ball catch clip, November 2024, the robot tracks a fluorescent tennis ball traveling at approximately 11 meters per second, about 40 kilometers per hour, and grabs it in 380 milliseconds, with no visible signs of remote control. By May 13, 2025, a second video from Tesla's Austin lab showed 2 Generation 3 units executing a 32-beat shuffle step in sync. Hips, knees, and ankles remaining within plus or minus 1 degree of the intended path throughout the 47-second recording, a tolerance usually associated with motion capture puppets, rather than free balancing bipeds. Independent roboticists have noted that Boston Dynamics Atlas still clears bigger jumps, but Optimus now claims the most articulated production hand in the industry. The jump in coordination is inseparable from an equally aggressive software overhaul. Tesla abandoned classical joint space control in favor of a vision-first stack ported from its full self-driving program. A deep dive explains that Optimus now operates using a streamlined version of the photon-to-control pipeline. 8 global shutter cameras provide input to a transformer-based neural network running on Tesla's full self-driving system on chip, generating 100 Hz volumetric scene graphs. These are then integrated into a model predictive controller that operates at 500 Hz. Latency from image frame to torque command is down to 23 milliseconds, roughly half the figure disclosed for Gen 2 last year. Even more significant is what happens between demos. On May 29, 2025, The Optimus X account posted a clip of the robot folding t-shirts after simply watching 45 minutes of first-person GoPro footage, a switch from teleoperated imitation learning to video-only self-supervision that Tesla says slashes human teaching time by 70%. Beneath the outer shell, Gen 3 is both lighter and more enduring. A teardown shared with Interesting Engineering estimates the frame weight at 125 pounds, 57 kilograms, driven by 40 electromechanical actuators and powered by a 2.3 kilowatt-hour structural spine battery. This enables the robot to operate through an 8-hour mixed task shift, or 4.5 hours of continuous walking at 5 miles per hour. Power consumption at idles around 100 watts and peaks near 500 watts when carrying a 45-pound payload. Figures that place the robot's energy cost of transport below 2 joules per kilogram per meter, already within the broad efficiency range of adult humans. These metrics translate into tangible improvements in capability. Pinch force increases from 8 newtons to 24 newtons, enabling the robot to pick up a raw egg without breaking it, or tighten a 6mm bolt to the specified torque on Tesla's 4680 battery production line. Cycle-to-cycle repeatability in a 3-point pick-and-place task, tested over 1,000 repetitions, shows positional drift limited to 0.6 millimeters, comparable to mid-range SCARA robotic arms that cost as much as the entire robot. The upgraded proprioceptive system, featuring 6-axis inertial measurement units in every limb segment, feeds into a reflex loop fast enough to withstand a 15-kilogram lateral shove. Logs from the Austin demo show center of pressure recovery in 620 milliseconds, with a maximum ankle deflection of 4.3 degrees. By integrating sensing, actuation, and control on a common FSD-grade silicon substrate, Optimus Gen 3 achieves a level of whole-body compliance that begins to look less like scripted robotics and more like biological motor control. Taken together, the 22 degrees of freedom hand, sub-30 millisecond vision loop, and full-shift battery endurance are redefining what a PUBR general purpose truly means in the realm of humanoid robots. Where Gen 1 merely waved, Gen 3 assembles wiring harnesses, stock shelves, and performs solder reflow, tasks that demand human-level finger finesse, not just locomotion. The result is a platform inching toward the threshold at which robots stop being novelties and start filling genuine labor gaps, both on Earth and, if Elon Musk's Mars timetable survives, on other worlds.
This is a super big deal. Like my prediction is that, on this front, is that Optimus will be the biggest product of all time by far. Nothing will even be close. I think it'll be 10 times bigger than the next biggest product ever made.
Mention the term humanoid robot, and many of us, myself included, can't help but envision a sleek, high-tech future where machines effortlessly take over the laborious, risky, or simply tedious tasks we'd rather avoid. Imagine a household assistant that whips up dinner, scrubs the dishes, and handles every mundane responsibility. Tempting, isn't it? Yet, alongside that optimistic vision lies a more anxious narrative. A growing number of people express unease, fearing that such advancements could displace human workers, or even lead to a dystopian scenario where machines dominate us, echoing the plot lines of countless science fiction thrillers. Of course, not everyone sees humanoid robots as the future. For many, they're still little more than awkward, clunky machines, expensive bundles of sensors and wires that can barely stay upright. Some compare their gait to a confused partygoer at 2 a.m., or even poke fun with political jabs. Honestly, the criticism isn't entirely off base. A lot of these robots still struggle to demonstrate real-world usefulness, and it's no surprise that skepticism runs high. But here's the thing, something noticeable has shifted. In just the past couple of years, progress hasn't been incremental, it's been dramatic. We're not just seeing refinements, we're witnessing a leap forward. Not long ago, the spotlight was mostly on Tesla's Optimus and Boston Dynamics' Atlas. Now, it's a full-blown global competition with companies across continents, from the US to China, racing to redefine what humanoid robots can be. To be clear, This isn't about declaring Tesla the undisputed leader in robotic innovation. But if we're talking about meaningful impact, robots that could genuinely transform everyday life, Optimus might just be the one to watch. With a straight face on CNBC last week, Elon Musk repeated a figure that has now become the fulcrum of every discussion about Optimus Gen 3: under $20,000. Musk says that once the Fremont pilot line clears a cadence of 1 million units a year, total bill of materials plus overhead should fall to about $10,000, leaving Tesla free to sell each humanoid for roughly the cost of a used Corolla while still pocketing automotive-class margins. By comparison, a 6-axis Fanuc M20 industrial arm with less than half Optimus's reach retails near $45,000 before end-of-arm tooling, and Hyundai-owned Boston Dynamics still quotes mid-six-figure leases for Atlas. Price alone, therefore, explains why Morgan Stanley's robotics desk values the addressable humanoid market at $5 trillion by 2050, with Tesla the early cost leader. The repercussions of that sticker shock were immediate. When Tesla opened a non-binding reservation portal on May 17th, the form collected 5,000 corporate expressions of interest in the first 72 hours, according to a live walkthrough filmed at Giga, Texas, and later confirmed by staff email to reservation holders. Logistics giant GXO booked 750 units for third-shift palletizing. German grocer Rui asked for 300 to pilot shelf restocking, and Thailand's Bumrungrad Medical Center reserved 120 for nighttime linen runs, 3 sectors with diametrically different wage structures agreeing on one thing. At $20,000, the payback period on a single-shift deployment falls well below 14 months even before tax incentives. Tesla's own internal math is starker. A robot running 2 8-hour shifts in Austin at $18 per labor hour yields an annual EBITDA of $90,000 against $2,000 in electricity, implying the robot repays itself in about 10 weeks and then compounds cash like a rental property with no roof to leak. Crucially, demand is not being throttled by production capacity forever. In January, the company disclosed that its first dedicated humanoid line is already cycling 1,000 units per month, with a second line under construction that scales to 10,000 units monthly by the fourth quarter 2025. 2 months later, an all-hands meeting leaked to Teslarati quoted Musk daring engineers to build a Legion, 5,000 fully assembled bots, before New Year's Eve, and to stock parts for 10 Legions in 2026. Wall Street took the hint. During the first quarter earnings call on April 22nd, Musk told analysts he is comfortable forecasting 1 million units a year by 2029, 4 years ahead of an earlier 2030 target. That trajectory, if met, would make Optimus the fastest ramping hardware product in consumer history, 10 times quicker than the Model 3 and nearly on pace with iPhone's early growth curve. Yet volume alone does not account for the breadth of the order book. Business Insider's roundup of Musk's spring media blitz notes that Tesla has already earmarked thousands of bots for in-house use before outside deliveries begin, effectively turning the Gigafactories into 24/7 showrooms where every visitor can watch a robot do value-adding work. Analysts see that dog food strategy as a demand accelerator. Each Optimus that spots welds a battery tray in Austin or shuttles a kitted tote in Berlin serves as a 5'8" salesman wearing no tie. Add the fact that Tesla plans to lease robots at $3,000 down and $2 per operating hour, a figure buried in a Wall Street analyst note that circulated after the Texas demo, and even smaller firms can de-risk adoption by matching payments to direct productivity gains. Behind the scenes, the economics are reinforced by Tesla's well-worn playbook of vertical integration. The same 48-volt powertrain architecture harvested from the refreshed Model 3 slashes inverter costs, while standardized actuators, fabricated on idle gigapress capacity, drive down unit CapEx per joint. Meanwhile, Dojo's wafer-scale accelerators, amortized over the still-growing FSD fleet, handle motion planning inference at 23 milliseconds, end-to-end. meaning Tesla can bundle lifetime cloud compute inside the $20,000 headline price instead of charging a monthly fee. No rival can yet match that subsidy because no rival owns the silicon, the battery cells, and the factory floor. Taken together, the under $20,000 target upends every spreadsheet in industrial automation, and the near-instantaneous flood of reservations hints at a backlog that could dwarf early Model S waitlists. Whether Tesla hits the ramp is a separate operational question, but on unit economics and visible demand, the numbers already clear the bar. If Optimus Gen 3 truly lands at car money prices while delivering round-the-clock labor, the robot risks becoming not merely Tesla's next big product, but the standard labor commodity of late 2020 capitalism. The first time in history the price of a humanoid drops below the annual wage of the human it is designed to replace. The Mars window that opens in late 2026 has become the organizing clock for everything SpaceX does, and Optimus Gen 3 has just been written into the countdown. Speaking from the Starbase launch site on May 30, 2025, Elon Musk said, "The first uncrewed Starship to the Red Planet will fly in that window, with a simulated crew consisting of one or more Tesla-built humanoid robots, rating the schedule a cautious 50 and 50, but insisting the attempt will go ahead even after the 9th Starship test ended in a loss of vehicle 2 days earlier, which retains 80% of its capacity at minus 20 degrees Celsius." According to the Universe Space Tech Brief, the Mars variant adds a multi-layer Kevlar polyamide skin for micrometeoroid grit and swaps the glass fiber covers for aerogel-lined carbon panels that keep core electronics above 5 degrees Celsius without the use of heaters. The first tasks are brutally practical: deploy rollout solar wings, trench cable runs, anchor Starlink Phase 2 dishes, and stack regolith Lego bricks into 2-meter berms that have surface radiation and block 90% of dust lift wind. Musk believes a squad of 30 robots working 2 8-hour shifts could raise a 100-kilowatt power station and berm a 1,000 square meter landing pad in approximately 90 Martian solar days, shaving a whole launch window off the timeline for crew arrival. So can a $20,000 robot truly survive Mars better than trained astronauts? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos.
Tesla remains just as committed and excited to bringing Semi to scale next year in 2026.
Since Dan Priestley's keynote at ACT Expo 2025, nearly every article on the Tesla Semi has hammered the same talking points: a 500-mile range, a 1-megawatt charger, and a massive Nevada plant capable of turning out 50,000 units a year. Those facts matter, to be sure, but they barely scratch the surface of how this truck could reorder the entire U.S. freight economy. The bottom line is that fleets today are still viewing the Semi through a diesel versus electric lens, missing out on far greater economic opportunities. The numbers in today's episode aren't speculation. We're using real market prices and peer-reviewed data to shift the question from "will the Semi work?" to "how will your bottom line quadruple with 50,000 Tesla Semis hitting the road?" Don't worry, we're not about to tell you to go take a driving test and start a trucking career. Welcome to Tesla Car World. But first, let's take a moment to determine whether the Tesla Semi has been so quiet. Is Tesla Semi real? Where is it? The ACT Expo 2025 keynote demolished cancellation rumors by unveiling hard evidence of momentum. Construction crews have nearly finished a dedicated 1.7 million square foot Gigafactory in Nevada that will scale to 50,000 semis a year, giving the program its own high-volume home instead of borrowing Model Y lines. Meanwhile, Tesla confirmed funding or permits for 46 public Megacharger stations, each pushing 1 to 2 megawatt, enough to add 350 highway miles in 30 minutes, forming an electric corridor from Los Angeles to Charlotte. On the road, the prototype fleet is anything but dormant. 26 trucks have already crossed the 100,000-mile mark, helping the total test mileage swell to 7.9 million miles. Lessons from that real-world data are feeding a product refresh that bundles a lighter HV battery, redesigned mirrors, and enhanced driver visibility. Pilot production continues through 2025, with a deliberate ramp toward volume in 2026, aligning supply chains and megawatt infrastructure. The Semi has traded splashy teasers for concrete execution, positioning itself to flip long-haul economics just as diesel costs, labor shortages, and carbon pressure converge. So, how does the Tesla Semi flip the economy?
It will be equipped with an MCS charge inlet, capable of more than 1 megawatt of charging. And then one other thing, we have a new HV battery. Now this battery brings in our latest and greatest in terms of technology. It is cheaper to manufacture. And the best part is that it's actually less battery energy than in our current pilot production vehicles. But it maintains the same range.
Think of every Tesla Semi as a rolling power bank, just a very big one. Dan Priestley says the new HV pack stores almost 1 megawatt hour of energy. For context, that's enough electricity to run an average U.S. home for more than a month. Now, picture a modest regional distribution center that owns 20 semis. When the night shift starts, those trucks are usually parked out back, connected to chargers and doing nothing else. Together, they hold about 20 megawatt hours of stored energy, roughly the daily output of a small solar farm. Tesla already built a two-way plug called EPTO on the Semi. It normally sends 25 kilowatts of power forward to things like refrigerated trailers. Flip a software switch, and it can send the same amount backward to the building. In other words, the fleet yard is secretly sitting on a pop-up power plant. California's grid operator, CAISO, publishes real earnings for batteries that sell energy or stabilize the grid. In 2021, a 6-hour battery earned a median $63 per kilowatt per year. The busiest locations earned more than twice that. To stay conservative, let's slash those numbers by 40%, because truck batteries might only discharge for 2 hours at a time and lose a bit of energy each cycle. Even after that haircut, a warehouse that lets its parked semis push 300 kilowatt back into the grid for 4 hours on a scorching summer evening could collect somewhere between $75,000 and $90,000 a year. Last summer, CAISO accepted 1,400 megawatts of demand response power. That means regulators already trust mobile storage, and fleets can get paid for joining the club. A real-world example of PepsiCo Bakersfield makes it tangible. PepsiCo's snack plant in Bakersfield, California, already uses a handful of semis. Imagine 5 trucks roll in at 7 p.m. each with 40% charge. Together, that's 5 megawatt-hour on standby. They feed 2 megawatt-hours into the local microgrid when electricity prices spike to $170 per megawatt-hour, based on a real evening price from February 2025. They top back up after midnight when power drops to $55 per megawatt-hour. Profit for that single night, about $230. Do that every day and the total tops $84,000 a year, before counting extra income from California's low-carbon fuel standard credits for running electric instead of diesel refrigeration units. We'll revisit those credits later, but the takeaway is clear. Parked semis can earn money while drivers sleep. A diesel tractor starts losing value the moment you shut off the engine. Accountants call it a cost center. But a Tesla Semi flips the script. The truck's battery can smooth out frequency swings or shave peak demand. Utilities pay real cash for those services. A full 1 megawatt-hour pack can keep lights, servers, and forklifts running in a 200,000 square foot warehouse for roughly 4 hours during a blackout. Many California businesses pay hefty penalties when their power draw leaps for even a few minutes. Trimming a 400 kilowatt spike saves about $67,200 per year at today's demand charge rates. Add those 3 streams together, and over a 10-year life, a single semi can recover $300,000 to $400,000. of its purchase price before you even count cheaper electricity or lower maintenance. Why does the Tesla Semi help protect truck drivers' rights? The U.S. trucking industry is confronting a critical labor shortage. Veteran drivers are leaving faster than recruits can replace them. Most people see it as tough and even dangerous work. Long-haul deliveries mean constant fatigue, sleep deprivation, and exhaustion. Add to that the engine noise, the wind noise. It's brutal. The American Trucking Association reports a deficit of roughly 82,000 drivers at the close of 2024, a figure that could surge to nearly 160,000 by 2030 if current trends persist. This widening gap threatens to disrupt supply chains nationwide. Every time a driver quits, a fleet has to advertise, interview, drug test, train, and let a truck sit idle. When you add all those steps together, the price tag averages $12,799 per driver, based on a 2024 figure. Multiply that by tens of thousands of empty seats and the industry is burning more than $1 billion a year just replacing people. That's money nobody gets back. But from the moment a driver settles into a Tesla Semi, the difference is striking. The electric powertrain trades the 80-decibel roar of a diesel cab for a cabin ambiance below 60 decibel, quiet enough for easy conversation and noticeably easier on the nerves. That calm is matched by the truck's seamless acceleration. With full torque available from a complete stop, the driver no longer wrestles with gear changes or dreads the surge of traffic while merging. What used to be a tense, engine-screaming sprint onto the highway becomes an effortless glide, saving both concentration and energy. In a PepsiCo trial, a single Tesla Semi covered 1,076 miles with only a quick change of drivers rather than the usual queue of diesel fill-ups, DF refills, and oil checks. Every avoided fuel stop converts idle minutes into revenue earning distance, precisely the metric drivers say keeps them in the profession. Quieter, smoother, and more profitable, the Tesla Semi changes the very texture of a long-haul shift from day one. Besides, when Frito-Lay tested the Semi between Modesto and Reno, managers said that the new trucks helped with driver retention. Let's do the math. In a fleet of 250 tractors, the company typically loses about a quarter of its drivers each year. Trimming that churn by even 10%, down to 22.5%, means 25 fewer resignations. Replacing a long-haul driver costs roughly $12,799 in recruiting, onboarding, and training. So the change translates into an annual savings of about $319,975. That figure almost equals what the entire fleet spends to burn 7 cents worth of diesel for every mile it travels. And the calculation touches only the hiring ledger. It leaves out the quieter gains of steadier service, fewer accidents, and more satisfied customers that come with keeping experienced drivers in the seat. To be more careful, scientists at Southwest Research Institute strapped sensors on veteran drivers and measured heart rate changes and tiny steering corrections. They found noise and vibration trigger 38% of fatigue during a 600-mile day. Take away the rumble and the shake, and a driver can stay in the alert zone for an extra 1.2 hours. That's just enough to finish a typical 550-mile shift without flirting with hours of service fines or worse, nodding off. So the question isn't only how much cheaper is a mile of electricity. It's also how many good drivers will stay if we give them a quieter, cleaner, stress-free cab. For fleets bleeding talent, the answer could be worth more than any savings at the pump, and the Tesla Semi hands them that advantage on day one. How does the Tesla network boost the Semi range to 625 miles?
Very beginning of a dedicated, publicly available charging network for semis. These 46 sites are already in progress and represent more than 300 megawatt capable posts that will start going into the ground this year, with many more to fall in 2026.
Forget slow chargers hidden behind chain link fences. Tesla has now funded or permitted 46 public Megacharger stations and says they'll all be online by 2027. Each stall delivers 1 to 2 megawatts of juice using the new MCS plug. That is powerful enough to pour 350 highway miles into a semi in half an hour, about the time it takes to grab coffee, stretch, and check cargo straps. Plot those 46 stations on a U.S. map and a clear pattern pops out. Picture yourself behind the wheel of a Tesla Semi rolling out of the port of Los Angeles. Scattered across the country, 46 fast charge stations line up like an invisible electric rail running through Phoenix, Dallas, Memphis, Atlanta, and finally Charlotte. With these pit stops in place, you can top up in Phoenix, switch drivers in Dallas, and drop your load in Atlanta, all in about 36 hours without burning a drop of diesel. Each stop offers more than a plug. After dark, parked semis can send excess energy back into the depot like mini power plants, trimming the facility's power bill. They're also genuine rest hubs. Quiet sleeper berths and lightning-quick handoffs replace the grind of waiting around cheap motel lobbies. The result? Both truck and crew are ready to roll sooner and lighter. Besides, a research team writing in scientific reports modeled 3 and 4 truck platoons and found they cut aerodynamic drag by 11% to 25%. Because an electric truck counts every kilowatt hour, that savings turns a 500-mile battery into a 560 to 625-mile battery. In practice, a convoy leaving Phoenix could roll all the way to the Dallas Charger without stopping. Dan Priestley reminded everyone that every semi comes with hardware 4, the same computer Tesla plans to run its hands-free, full self-driving package on later in 2025. So picture this. 1 human drives the lead truck. 2 driverless semis follow a few car lengths back, linked by digital tow ropes. The trio glides from charger to charger, braking only for the lead driver's mandatory rest. Labor cost drops by roughly 2/3 per mile, a stunning shift in an industry where wages and benefits are often the single biggest line item after fuel. At the April 2025 average diesel price of $3.56 per gallon and an efficiency of 6 miles per gallon, every mile a conventional diesel tractor travels rings up about 59 cents. The same mile in a Tesla Semi, drawing roughly 1.6 kilowatt-hour, costs only 21 cents at the U.S. average electricity rate of 12 cents and 32 hundredths per kilowatt-hour. Run 3 semis in a platoon, aerodynamic drag falls another 15%, and the cost slides to about 18 cents per mile. Put plainly, even at average electricity prices, a platoon of semis spends less than 1/3 of what a diesel rig pays just to keep moving, and the gap grows wider if diesel spikes, or the trucks recharge on off-peak night rates. Because megachargers land roughly every 200 to 250 miles, dispatchers can redraw their maps around tidy 3-hour driving legs, the same way airlines schedule flights through hub airports. That simple shift sets off a domino effect, free hidden wins. Shorter dwell times. Freight doesn't sit waiting for a driver's 10-hour break. It swaps cabs and keeps rolling. Lower detention fees. Warehouses pay less for trucks stuck at docks. Faster asset turns. One tractor can cover more loaded miles per month, so fleets grow revenue without buying extra iron. These network effects rarely show up in straightforward diesel versus electricity spreadsheets, yet they may dwarf the fuel savings over time. In essence, Tesla's Megacharger lattice isn't just a set of plugs. It's the backbone of a new high-speed freight mesh that lets goods move as smoothly as data packets on the internet. Fleets that plug in early will own the fast lanes, while everyone else is still hunting for the next truck stop. How did the Tesla Semi earn $22,409 from carbon credits? If you operate trucks in California, you probably followed the state's Advanced Clean Fleets rule. It was set to be the toughest electric truck mandate in the country, until 6 May 2025, when a coalition of 17 states led by Nebraska convinced a federal court to put it on ice. One day, fleets were bracing for strict zero-emission targets. The next day, those targets vanished. That wild swing shows why policy risk cuts both ways. If you spend big money on new diesel rigs and the rules flip back tomorrow, those shiny tractors could turn into expensive paperweights. On the flip side, if you already own zero-emission assets and the credits they generate, a sudden clampdown becomes a golden opportunity. The Tesla Semi lets you sit on the winning side of either outcome. So how to earn carbon cash? Right now, you don't have to wait for future laws to start making money. 2 credit programs already pay fleets for clean miles, such as low-carbon fuel standard credits in California. Every electric mile avoids roughly 1.6 kilograms of carbon dioxide. Drive a Semi 100,000 miles and you skip about 80 tons of carbon dioxide a year. Current market price with $59.49 per ton. Annual payout approximately $4,760 per truck. Or eRINs by federal proposal. The EPA plans to award 1 electronic renewable identification number for every 6.5 kilowatt-hours of clean electricity used as vehicle fuel. The Semi burns about 1.6 kilowatt-hour per mile, so 120,000 miles consumes 29.5 megawatt-hour, good for 4.5 million eRINs. Even at a cautious $1.70 each, that's another $7,650 in digital fuel credits. So, if Tesla has already proven 7.9 million miles and built 46 Megacharger stations, why are fleet managers still hesitating to adopt the Semi? What exactly are they waiting for? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos.
I do think Tesla Semi, again, with autonomy, is going to be incredibly valuable.
The Semi is a TCO no-brainer. It as a total cost of ownership, it's much, much cheaper than any other transportation you can have.
Elon Musk recently confirmed that 2025 is the best time to buy a Tesla Semi, with potential savings of up to 22% on total cost of ownership. In just the next 5 years, stricter regulations on operating Class 8 trucks, along with increased safety inspections and fines for traffic violations, could make profitability even more challenging. Local governments may impose tighter controls, turning minor infractions into costly penalties. In this evolving landscape, the cutting-edge technology of Tesla's electric trucks presents a game-changing solution, helping operators avoid these pitfalls while maximizing efficiency and savings. The Tesla Semi has proven its capabilities with a 500-mile range on a single charge and the ability to recharge up to 70% in under 30 minutes. Thanks to Tesla's advanced in-house battery technology, the Department of Transportation, DOT, will not need to raise the current 80,000-pound weight limit, giving the Semi a significant advantage over traditional diesel trucks. But what exactly sets Tesla's electric truck apart? And why is developing a battery-powered Semi such a groundbreaking achievement? In today's episode, we're diving into 4 key reasons why Elon Musk is confident that Tesla's electric trucks will dominate the market in 2025. And reason number 4 is almost unbelievable. Welcome to Tesla Car World. Despite accounting for just 1% of total vehicle production, trucks are responsible for 20% of all emissions and over 1/3 of particulate matter. Even more concerning, they contribute the majority of carcinogenic diesel emissions, posing significant environmental and health risks. At the Tesla Semi launch event, Elon Musk declared it to be a superior product in every aspect. Not only does it boast cutting-edge features, but it also delivers a compelling economic advantage over diesel trucks, even under the most challenging conditions. In some cases, it could even rival rail transport. However, developing the Tesla Semi isn't as simple as just installing batteries, adding an electric motor, and marketing it under Musk's vision. Creating a truly groundbreaking electric truck requires overcoming significant engineering challenges to ensure the final product is not only functional, but also practical, scalable, and capable of meeting real-world transportation demands. How will the 2025 tax policy changes benefit truck drivers? As Elon once said, "I don't know why a trucking company wouldn't want to save money. It's all about fuel." For example, Jake, a 47-year-old truck driver from California who recently shared his experience. According to him, the cost of a new diesel sleeper truck today can reach $250,000 after all necessary paperwork and fees. But that's just the beginning. The real expense comes from fuel. Over 8.19 years of operation, a diesel truck will burn through $620,000 in fuel costs. In contrast, a Tesla Semi would only require $155,000 in electricity over the same period. That means the true cost of ownership for a Tesla Semi, priced between $180,000 and $250,000, is an absolute bargain when factoring in long-term savings. With major political shifts in the U.S. in 2025, regulations surrounding the electric vehicle market have also changed significantly. One of our biggest areas of focus right now is the tax credit provisions under the Inflation Reduction Act and how they will impact the industry moving forward. As we know, the Trump administration has issued an order to end federal tax credits for EV purchases, eliminate federal subsidies for charging stations, and halt loans and grants supporting assembly line upgrades and battery manufacturing facilities. This sudden shift will undoubtedly cause confusion among many consumers. However, Elon Musk has made it clear that he doesn't rely on government incentives or tax credits to make the Tesla Semi cost-effective. That said, the provisions in the Inflation Reduction Act, IRA, would have made the EV market even more financially attractive. As long as Tesla and other U.S. electric truck manufacturers meet the requirements for using domestically produced components and batteries. Under the new law, qualified buyers of heavy-duty electric trucks can receive a $40,000 tax credit, equivalent to up to 15% of the cost of a traditional diesel semi-truck. However, pricing details for many electric truck models remain somewhat unclear. In addition to federal incentives, major states like New York and California are offering rebate programs that reimburse part of the cost for heavy-duty electric trucks purchased within their jurisdictions. For those unfamiliar with how this tax credit works, here's a quick recap. To qualify for Tesla's 2025 EV tax credit, certain key conditions must be met. The vehicle must be a new Tesla, purchased for personal use, and comply with the manufacturing and sourcing requirements established by the Inflation Reduction Act. These rules dictate that the vehicle's final assembly must occur in North America and that a specific percentage of its battery components must be sourced from North America or countries with U.S. free trade agreements. Additionally, income restrictions apply to eligibility for this tax credit. In 2025, the exact tax credit amount for Tesla vehicles will depend on battery capacity and vehicle classification. Larger battery packs typically qualify for higher incentives, making certain models more advantageous than others. For instance, the Model Y Long Range may receive a higher credit than the Model 3 Standard Range Plus. Similarly, the Tesla Semi, offering up to 800 kilometers or 500 miles of range per charge, could qualify for a larger credit than smaller EVs. Based on the current provisions of the Inflation Reduction Act, the Internal Revenue Service, IRS, allows commercial electric vehicles to receive up to $40,000 in tax credits, depending on battery size and intended use. Given its heavy-duty classification and long-range battery, the Tesla Semi is likely to be eligible for the maximum incentive, making it an even more compelling choice for fleet operators looking to cut costs. In 2025, tax credits for electric vehicles will vary based on classification and battery size. Personal EVs can receive up to $7,500, while heavy-duty commercial EVs like the Tesla Semi may qualify for up to $40,000 or 30% of the vehicle's price, whichever is lower. With the Tesla Semi's estimated cost ranging from $180,000 to $200,000, this tax credit could significantly lower the upfront investment. However, the final amount will depend on IRS regulations in 2025. Andrew, a seasoned truck driver with over 5 years of experience, is considering purchasing a Tesla Semi priced at $180,000. With an assumed $40,000 tax credit, his effective cost drops to $140,000, providing substantial financial relief. This reduction directly offsets his tax liability, making the Semi a more attractive investment. The savings could be reinvested into insurance, maintenance, or other operational expenses, enhancing affordability and increasing the appeal of transitioning to electric trucking. Let's take a real-world example from DHL and Saia. In California, where the average electricity price makes each 1.7 kilowatt-hour cost approximately $0.3 per mile, a Tesla Semi traveling 6.5 miles would only incur an energy cost of around $3.3. In comparison, a diesel truck consuming 1 gallon per mile would incur a fuel cost of around $3 per mile. 6.5 miles would cost about $3.66 at current fuel prices. While this per-mile difference might seem minor, when scaled to hundreds of thousands of miles annually, it translates into massive savings for fleet operators. However, fuel savings are just the beginning. One of the Tesla Semi's most disruptive advantages lies in its simplified, ultra-efficient design, which completely redefines traditional trucking. Unlike diesel trucks, laden with bulky combustion engines, complex gearboxes, and hundreds of moving parts prone to wear, the Tesla Semi eliminates nearly all of these failure points. This translates into drastically lower maintenance costs, saving companies tens of thousands of dollars annually. Tesla estimates that the Semi's maintenance cost is only 10 cents per mile, meaning a driver logging 100,000 miles per year would spend just $50,000 over 5 years. In contrast, a traditional diesel truck costs around 20 cents per mile, doubling the expense to $100,000 over the same period. But the savings don't stop there. Diesel trucks are not only more expensive to maintain, but they also require frequent servicing, including engine oil changes, exhaust system repairs, and complex internal engine maintenance. Every service downtime not only adds expenses, but also takes trucks off the road, disrupting logistics and cutting into a company's bottom line. How superior is the Tesla Semi Gen 2's operating range? With the Tesla Semi, everything is much simpler. Fewer breakdowns, less time spent on maintenance, and lower operating costs. On steep inclines with heavy loads, it isn't just more powerful, it's also far safer. Tesla claims the Semi can accelerate from 0 to 60 miles per hour in just 20 seconds, even with a full load on a 10% grade, an impossible feat for a diesel truck, which risks tipping over under similar conditions. The Tesla Semi currently operates with a 900 kilowatt-hour battery pack, consuming 1.7 kilowatt-hour per mile, enabling a verified range of up to 500 miles during testing. However, Tesla plans to transition to 4680 battery technology in the next generation Semi, which will be produced at a new facility instead of continuing with the current 2170 cells. Switching to 4680 batteries could represent a major leap in performance for Tesla's electric semi-truck. With a significantly larger size, the 4680 cells offer approximately 5 times the energy capacity and 6 times the power output compared to the 2170 cells. This allows the Semi to achieve greater range without requiring a substantial increase in battery cell count, an especially critical factor for electric trucks, as reducing overall vehicle weight enhances freight carrying capacity. The Tesla Semi boasts remarkable durability, with an operational uptime of up to 95%, including all maintenance. One Semi has logged over 250,000 miles in just 1.5 years, proving its reliability before requiring major servicing. In contrast, diesel trucks become increasingly expensive to maintain over time, diminishing their long-term economic viability. Advancing battery energy density is the key driver behind the next era of electric vehicles, and Tesla has led the charge with cutting-edge innovations in this space. In reality, there's no proprietary Tesla technology that companies like BMW or Ford couldn't replicate and refine. That's why Elon Musk is doubling down on vertical integration, shifting toward a more closed-loop manufacturing process. The 2025 Tesla Semi will feature Tesla's in-house 4680 battery cells, replacing the 2170 cells used in earlier versions. Tesla's battery technology, at its core, is a masterclass in branding and marketing. To determine the energy required for different truck variants, engineers first calculate the total energy consumption over a given range. This involves accounting for the force needed to overcome inertia, air resistance, rolling friction on the wheels, and gravitational force when climbing inclines. From these calculations, the necessary battery capacity can be accurately defined. Tesla reports that the Semi boasts an astonishing drag coefficient of just 0.36, sleek enough to outperform even a Bugatti Chiron in aerodynamic efficiency. How does the Tesla Semi Gen 2 performance beat the rivals? In the U.S., heavy-duty semi-trucks are classified as Class 8 vehicles, with a federally mandated maximum weight limit of 80,000 pounds, 36 tons, including both the truck and its cargo. Any increase in the truck's weight directly reduces its payload capacity, a critical factor in the freight industry. Unlike fossil fuels, batteries have a lower energy density, making it a significant challenge to design an electric truck that is both practical and competitive in long-haul logistics. If a truck without batteries weighs around 15,000 pounds, 7 tons, that leaves 64,000 pounds, 29 tons, for both the battery pack and cargo. This presents a crucial design trade-off. Because more batteries extend driving range, but reduce cargo capacity. And fewer batteries increase cargo capacity, but limit range. So what is Tesla's solution? Elon Musk has estimated that the Tesla Semi isn't just fast, it redefines freight capacity. While its 0 to 60 miles per hour acceleration in 20 seconds under full load is impressive, the real game changer is its lightweight design. With an empty weight of approximately 27,000 pounds, the Tesla Semi can carry up to 44,000 pounds of cargo, matching or even exceeding many diesel rivals. By optimizing efficiency, the Tesla Semi enables businesses to transport more goods per trip, maximize revenue, and achieve a return on investment in under 2 years. In an industry where every pound and every mile matters, the Tesla Semi offers a clear financial and operational advantage. How did Tesla secure the charging system for the Tesla Semi? At the beginning of 2024, the number of Tesla supercharger stations across U.S. states saw impressive growth. California led the way, with 426 stations and 8,361 charging ports, reflecting the state's high EV adoption rate. Florida and Texas followed closely, with 150 and 149 stations, providing 1,992 and 2,178 charging ports, respectively. States like New York, Pennsylvania, Virginia, New Jersey, North Carolina, Washington, and Illinois each had between 56 and 85 stations, with a total of 932 to 1,100 charging ports. The rapidly expanding supercharger network continues to support the nationwide transition to electric vehicles. Tesla's approach to scaling up the Semi is both strategic and methodical. By starting with limited production, the company gathers real-world feedback from drivers, fleet operators, business owners, and regulatory agencies to refine the vehicle before ramping up mass production. A great example of this strategy in action is Frito-Lay's Modesto facility, which underwent a transformation in 2019 to showcase the benefits of zero-emission and near-zero-emission technologies. This project successfully reduced greenhouse gas emissions by 91%, demonstrating the potential of electric trucking. PepsiCo took this initiative even further by partnering with the California Air Resources Board and securing a $15.4 million grant to acquire electric trucks, including the Tesla Semi. By December, PepsiCo had taken delivery of the first Tesla Semis and quickly integrated them into their fleet. The company stated that it took only a few weeks to install, apply branding, label the trucks, and train drivers. To support these new vehicles, Frito-Lay installed 4 Tesla Megachargers, each capable of delivering 750 kilowatts of charging power. Preliminary cost-benefit analyses indicate that Tesla Semi offers massive economic advantages, not just for Tesla, but also for its future competitors. The Tesla Semi is proving to be a game-changer in range and charging efficiency. The first-generation model offers an impressive 500-mile range and can recharge to 70% in just 30 minutes using Tesla's proprietary Megacharger technology. Tesla has committed to rapidly expanding this charging infrastructure, making long-haul electric trucking more viable than ever. By 2026, when full-scale commercialization begins, the Semi's range is expected to increase significantly, while charging times could drop by more than 30%. With the 750-kilowatt Megacharger network already in deployment, Tesla is leading the industry in battery energy density and charging efficiency. Let us know what you think in the comments section of this episode. Thanks.